So for number 1, part A, the directions say for this function right here, we need to find the inverse. We know that we're trying to find the inverse because of the -1 little thing on that F symbol. Then after we find it, we want to state the domain and range for the function and the inverse. Now, I didn't put charts for the domain and range on here because that would just take up a lot of room, but that's essentially what we're going to be filling out is the chart about the domain and range. So the first thing you want to do when you're trying to find an inverse, remember, is you want to write this as y equals, just so it looks like you have your ordered pair x and y there. And we physically change the x and y as if we're changing domain and range. So we swap them. The goal is then to resolve this, because this is actually physically the inverse, it's just not solved for y. So we want to resolve this for y, which means we have to get everything away from it, just as if we were solving for any variable. So we're going to subtract over the 5. And then we can't add the 8 yet because it's all under this cube symbol. So we're going to have to take the cubed root of both sides. We do not need to write a plus or minus here because that only happens if you take an even root. And then finally we'll be able to add 8 over to finish. So this will become the cubed root of x minus 5 plus 8, and that is going to be my inverse function. And you do want to write the little f inverse of x. The next thing we do is, remember, we talk about the domain and range of the inverse and the function. So for this one, there's not really much interesting going on. The more interesting domain and range is the little fraction one that we've practiced over and over again. Because the first original function was just a polynomial. This has just got x cubed in it. So that means that anything you want can be plugged in. There's not any restrictions. And this is a cubed root of x. Cubed root of x is also something that has no restrictions because it's an odd root, not an even root. So since both of them have no restrictions, so do the ranges. Remember, they cross over and swap. So that's it for number 1A. Guys, let me know if you are okay with that one, and are we ready to move on to number 2? Okay, so let's move down to number 2. We had quite a few questions from number 2. So we're supposed to be graphing these, so I'm going to give myself some space here. For this first one, we are looking at f of x equals 2 to the x plus 3. If it's an exponential, which is what this is, it's a base with a variable for the exponent. The best and easiest way to graph is to just do a chart. Since x is the exponent, we're going to pick x's to plug in. So if we work this out, this would be 2 to the negative 2 plus 3. You can either use your calculator and type that in, or you can remember that negative exponents move something to the bottom. So that'd be 1 over 2 squared plus 3, which is 1/4 plus 3. That comes out to 3.75 if we add them together. And then 2 to the negative 1 plus 3 would be 1/2 plus 3, so 3.5. 2 to the 0 plus 3 would be 1 plus 3, so that would be 4. 2 to the 1 plus 3 would be 2 plus 3, so that would be 5. And 2 to the second plus 3 is 4 plus 3, which is 7. So that's my set of ordered pairs. And notice that is kind of looks like our asymptote is going to be at 3 because we never get low enough. And sorry, I wrote that wrong. That's not 3.75, it's 3.25. I just caught myself. So this looks like it's getting closer to 3, but never actually getting there. So let's plot the points. And this would be negative 2, and then up 1, 2, 3, a little bit above 3. Negative 1 is 3.5. 0 is at 4. And 1 is at 5. That should be enough points. So notice it does have my exponential shape that we like to see, And my asymptote is horizontal when we have an exponential graph, and this one is at y equals 3. So anytime you have a vertical shift, that's going to be your horizontal asymptote. It's going to be that number at the end. Is everybody okay with that one? So 2B. Hannah, I noticed that you just signed on. You are more than welcome to add questions, even if we've already got them highlighted. Just list out any questions that you have in the chat box, and I will add them to our list as we go. A does have an asymptote. Anytime you have nothing at the end on these exponentials, it is 0. Remember that the natural asymptote for an exponential is the x-axis, which is a y value of 0. That's a good question, G. Okay, so let's move down. You guys had a couple more from this section. So let's look at, I believe, 2D might have been the next one. Let me scroll it up a little bit. Yeah. Now notice this one's a little bit different because there is a +3 there, but it's no longer as a vertical asymptote. If it's in the exponent, it's going to be a horizontal asymptote. So if you think about it, this guy's also going to have his horizontal asymptote at +0, because you could think about a +0 being the vertical shift. But we can see that just from a table. So we're going to make the little table. Anytime you have an exponent that is not just the letter x, you want to consider very carefully what you put in the center of the table. So for us, we're going to think, okay, what would make x plus 3 center back at 0? And that looks like it would be -3. So to keep my graph looking the way I want to get this shape, I'm going to center my table at -3 to force the exponent to be 0 in the center. Then once you figure that out, you pick 2 things smaller and 2 things larger. So this would be 2 to the -5 plus 3, which is 2 to the -2, or 1 over 4, so that'd be 0.25. 2 to the -4 plus 3 is 2 to the -1, which is a half, or 0.5. 2 to the -3.3, notice that forces it to be 2 to the 0. Anything to the 0 power is 1. 2 to the -2 plus 3 would be 2 to the 1st. And 2 to the -1 plus 3 would be 2 squared, which is 4. So if we graph this one real quick. And by the way, on the test, when we say graph these, it'll say sketch, and it'll say at least plot 3 points and dash in your asymptote. So make sure you notice that I've plotted at least 3 points each time, and I do dash in my asymptote. So this would be -5, and then up 0.25. And then -4 is up a half. -3 is at 1. -2 is at 2. And -1 is at 4. So notice I'm still not crossing the x-axis, that's my asymptote, but I have shifted to the left 3 from the original direction that the graph usually is in. So we've moved the whole graph to the left 3 because of that horizontal shift. Is everybody okay with D part before I move on to the next one? And don't forget, I will post, I will always post the worked out examples of these after our video as well. The horizontal asymptote is 0. So Ali, if they don't have a plus or minus something at the end when you're doing exponentials, you are always fixated at 0, the x-axis. So yeah, I dashed it in, but it's hard to see. So anytime you don't have like a +3 or a -5 or something at the end of this exponential, you're going to just be centered right there at the x-axis. Does that answer your question okay? Okay, so let's look at our next one. We're going to need our calculator for E and F because they both have that E button involved. You do these the same way. You still do a table. The only difference is you got to use your calculator button. So I will pull up my little calculator in just a second. For this one, I'm still going to pick -2, -1, 0, 1, 2. Notice anytime you're doing an exponential graph, you're picking the x's. If you're doing a logarithm graph, you end up picking the y's. This is still number 2, so I've just spaced them out so I can write them. So this is 2e. So let me pull up my calculator. So my button works a little weird on this calculator. I have to enter the exponent first and then type in the e button. So -2, and then I tell it that I want that to be base e. So that's 0.14. And then I'm going to do e to the -1, which is 0.37. E to the 0 would just be 1. E to the first is just going to be e, but that's about 2.72. Yep, 2.72. And e squared, which is 7.39. So you just needed to figure out what those approximations are using that button on your calculator. Then you plot this just like normal. Notice there's no vertical shift on this one, so since it's an exponential, I should expect not to cross 0, which notice these get close to 0, but don't cross it. All right, that should be enough points. And then we dash in our asymptote, which I'm trying to kind of emphasize right there at 0. Is that one okay? I will come back to your side question in just a second, G, when we get to the log graph, okay? All right, so if we look at our last one under number 2, this is the last graph that you guys asked me for in this section. This is similar to the one we did just a minute ago. It's e to the x minus 1. So we're still going to be using the e button on our calculator. It's also going to still be centered at 0 for the asymptote. That's going to be the horizontal asymptote because there's no plus or minus anything after the exponent. With exponentials, only a vertical shift will change that dashed line. So then we plug in, here again though, I do have something in my exponent. I do want to be careful where I center my graph. So I'm going to do x minus 1 equals 0, so I need to center my graph at +1 because this is a shift to the right. So then I pick 2 numbers smaller and 2 numbers larger. That will force my shape to be exactly what I want. So this ends up being e to the -2, e to the -1, e to the 0, e to the first, and e to the second, which we know the answer to all 5 of those. E -2, e -1, e 0, e to the 1, e to the 2 are what we just did. So by going ahead and shifting your table, you get the same values. But when you graph it, you do have to realize you're graphing it pretty much shifted to the right one because you've shifted where the x is actually happening. And that was just to make all these exponents pop up the way that we like them to, from -2 to 2. So -1 is at 0.14, 0 is at 0.39, 1 is at 1, and 2 is at 2.72. So notice the graph is just barely shifted to the right one. Horizontal asymptote is exactly the same. So if you notice, pretty much the horizontal asymptote is always 0 unless there's a vertical shift on your exponential. That is different for logs. Logs don't work exactly the same. They don't have horizontal asymptotes, they have vertical asymptotes. So we're about to graph at least 1, maybe 2 of the logs real quick. Is everybody okay with the finished problems from number 2? So number 1 most important fact, don't forget your calculator. Because that was all I relied on essentially to be able to work that problem out. So very important. Okay, now G had a side question a minute ago that said, are log and natural log the same? They're both logarithms, but they have different bases. Log by itself is base 10. Natural log is a log base E. So anytime you see this natural log thing right here, like this E one right here, that's really log base E of negative x. That's what that actually stands for. We just don't write log base E. That's clunky, and that's just not how they do it. They write natural log. Notice that all the other ones up here are not even log base 10. They're all log base 2. So the buttons on your calculator are actually, one of them is base 10 and one of them is base E. That's the difference between those. Does that answer your question, G? Okay. So you guys asked for D. So let's try that one. That's a good one because that's actually when your asymptote will shift. In a log, your asymptote shifts not with a vertical shift, but with a horizontal shift. So let's remind ourselves, how do we go about graphing a log? The first step when graphing a log is to make sure that the log is isolated. What I mean by that is you can have the base and you can have an argument, whatever that argument is. It doesn't matter if it's one thing or two things, but it's in the parentheses. This is isolated. So on the other side, you'll have other stuff. As long as you have it isolated, the next step is to convert. Remember, we do our spiral. That was our little trick for that. After you do that, you're going to do a table and pick the y's. We're going to do it opposite direction. So for this one right here, I'm going to write this as y equals log base 2 of x minus 3. Notice that this log is isolated. There's nothing plus or minus at the end after the parentheses is ended, and there's nothing times it in front. So as long as there's nothing after the log or right before it, you can go ahead and do the spiral. So 2 to the y equals x minus 3. Just to help you have an easier time graphing, we like the x to be isolated since we're doing our table backwards, kind of. So we're going to add that 3 over just to make our calculator typing easier. Then we do a table. This time we pick the y values when we're doing a log, because remember, a log is the opposite of an exponential. It's got the y as the exponent, not the x. So since there's nothing up there but a y, if it had like a +1 or a +2, I would adjust my table, but it's just a y. So I'm going to pick -2, -1, 0, 1, 2. We're going to plug those into this, and we can use our calculator to help us, and that'll give us our x's. So I'm just going to write down each case. Obviously, these ones at the bottom are pretty easy. I'll go ahead and do those. So that's 4 plus 3, so that's going to be 7. 2 plus 3 would be 5. 1, because that's 2 to the 0, plus 3 would be 4. That would be 1/2, so that's 3.5. And that would be 1/4, so that's 3.25. Again, you could type that straight into your calculator if you needed to. So remember, logarithms are inverses to exponentials. They kind of have a shape where they're like this. I know you may not be able to see that. Let me make that bigger. Maybe you can see the cursor if I make it bigger. So they have this shape where they usually run up the x-axis, cross at 1, and then go up. Now ours has been shifted. Because there's a horizontal shift, we're going to have a shift in our normal vertical asymptote of x equals 0. So when we plot this, notice we go to 1, 2, 3, 3.25, so a little bit past 3, and then down 2. And then we go to 3.5 and go down to -1. We cross at 4, and then 5, 1 will be enough to get us a graph. So notice our vertical asymptote is no longer at 0, it's at +3. Because we get close to 3, but we don't actually cross it. We have decimals that are close to it. You could have known that just by looking at the inside of this. So when you're dealing with a log, whatever makes the inside 0 is where your asymptote is. So x minus 3, if you set that equal to 0, that means you can't cross the line +3. Another thing to note about logs is that the domain of a log, because it is restricted, is that the inside always has to be greater than 0. So if x minus 3 has to be greater than 0, the whole graph has to be on the right side of positive 3. So notice that's exactly what we have here. So that is a log graph. How do we feel about that one? Sure, I can do B part as well. Is that okay with everybody else if we add B into there? Let's see if it'll let me. It may not like me to do this. We'll see. Yeah, it split my graph. You silly thing. All right, hang on just a second. Sometimes computers don't like when you do things. All right, so let me move this down. I'm going to make sure that all the ink is there because remember, I'm going to post this later and we don't want to lose any of our writing. So there was a dash here and that was an arrow, and that looks funny. The inside, it has to be greater than 0. Okay. There we go. All right, so let's go back up and look at B. So for B, there is a little bit of an issue before you try to convert this. Write it as y equals negative log 2 of x. The log does not look isolated to me because I see there's a negative in front of it. So the first thing I'm going to do is divide everything by -1 to make sure that the log is over here with nothing in front of it and nothing added or subtracted at the end. You need to do that before the conversion step. So now I have negative y equals log 2 of x. So I'm going to do my spiral. So this would be 2 to the negative y equals x. We make our table. You don't have to change anything about the table. I know there's a negative there. That's just going to flip the order of all of what we get. So you can still do -2 to 2. When you plug in -2, though, you're getting -2 because you're plugging it into something that's already negative. So that becomes 2 squared. So that is 4. 2 to the -1 would be 2 to the first. 2 to the -0 would just be 2 to the 0. So that would be 1. 2 to the -1, though, would be a half. And that leaves this last guy to be a fourth. So notice all this does is flip the order in which we get our information. Instead of going from 1/4 to 4, we go from 4 to 1/4. And that does change the general shape of how the graph looks. Now it doesn't move the asymptote. That part didn't change because there was nothing inside the log that was a binomial. If there's no horizontal shift, then the log is still going to be centered at x equals 0 for the asymptote. So when we plot this one, we get 4, -2, so 1, 2, 3, 4, -2, let's see, 2, -1, it's right there, 1, 0, 1/2, 1, and 1/4 is 2. So notice your log is flipped upside down, which is kind of what you expect anytime you see a negative in front of a function, is that the graph just gets flipped upside down across the x-axis. But the vertical asymptote is still x equals 0 on this one. Does that answer that question for you? Okay, let's move down to the next question on our list, which was number 4. And we've kind of discussed some of this as we were going through it, so hopefully this will make a little bit more sense now. If we gave you this question on the test, because remember we always pick our test questions from similar things on the review, there would be 3 blanks to fill in: domain, range, and asymptote. because this is a log, if it's going to have a vertical asymptote, so I already know that this is going to be x equals something. If this was an exponential, where remember you have a number and then the x and the exponent, then we would know we'd have a y equals. The asymptote is always based off whatever makes this 0. So x minus 2 equals 0, x equals 2. So that part's done right there. In a log, the range is all real numbers because you go from negative infinity on your log and you keep getting bigger forever. The domain is also related to this part in here. So everything you need to know for a log is always based off of the parentheses because the range has no restrictions. So the domain is that x minus 2 has to stay greater than 0, just like when we solve the equations and plug them back in. So x is greater than 2. So that would be 2 without a bracket because there's no equal to bar to infinity. And that's it. So everything you needed to know about this was really there in that x part in the middle. The range, you just have to realize that a log goes down forever and it grows up forever. Because just look at the logs that we just graphed. All logs look exactly the same. Essentially, notice that, remember, the range is the y values. So see how this goes down forever? This little line right here, that means that we go down to negative infinity. This is not growing very fast, but this is always getting a little bit bigger. So as you go up, it doesn't really level off, it just gets bigger slower. So every y value up here could eventually be mapped over to some point on this graph. It's just going to take forever because it's growing really slow at that point. So because every number on the y-axis could possibly have an ordered pair on this graph, our domain is everything, or our range is everything. Because remember, range is related to how high or low the graph goes. And all logarithms go from negative infinity to infinity eventually, even though it takes them forever. Are we okay with that? So yeah, if you have this question on the test, you know that if it's a log, immediately you've got one of them right. You just have to know the range is everything. The other two pieces both come from that middle part. All right, let's look at number 5. That one was a question. So it says the amount remaining of a certain radioactive substance after t days is a of t equals a sub 0 e to the negative 0.0025 t, where a sub 0 is the beginning amount. And it says how much do we need to begin with if we want 80 grams after 10 days. So we don't know a sub 0. We want to have 80 grams left over after 10 days. So what that means is that this is the future value, a of t, and this would be our t. So if we plug that into that formula, so essentially this is just plug it in and work it out. That would be 80 equals, we don't know a sub 0, so we're just going to leave it as a variable. Remember, e is a number, and then this would be negative 0.0025 times the 10 days. If it was me, I would go ahead and work that out, 0.00. It's just going to move the decimal one place, but show it on here. And it was a negative for the other guy. So negative 0.025. Okay, so you're trying to solve for a sub 0. That means you need to get that e part to move away. Since it's connected by times, naturally, since there was no symbol here, we can divide the e part over. Whatever you do to the left side or right side, you have to do it to the other side. So that's why this is going over here as well. So this would be a sub 0 equals this, but we're going to get an approximation for that. So 80 divided by 0.025, which is negative to the e power, or excuse me, e base. Mine is backwards when I have to say it. That's 82.02. So because you don't, this is decaying, notice there's a negative exponent here. We usually round up just because we want to be safe. If they order only 82 grams, then it might decay down too much. So since that's over 82, even though it's a tiny amount, I'm actually going to round up to the 83 so that I know that I ordered the correct amount, and I might have some extra, but extra is better than not having enough. So usually with these, when you're solving for the initial amount, oh, it said rounded 2 decimal places, sorry. I wasn't reading my own directions. So that'd be 0.03. So we're going to keep the 82 and round to 2 places. So 82.03. And notice I did still round up on the decimal place. And that had nothing to do with the 5 being there. If that had been a 4, I still would have rounded up to make sure I had enough substance. So anytime you're looking for initial value, follow your rounding rules, of course, but make sure you always round up so that you don't have too little of that substance. Is everybody okay with number 5? I know, Ali, I think that was your question. Okay, so we're going to just keep moving along. Remember, the formulas for the money will be provided on the front page of the test. And for number 8, we wanted to look at 2 different questions, A and B. So let's look at those. A is writing it as a single log, so you're trying to put the logs together. Whereas B says break it up into adding and subtracting different logs. So that means we're going to be breaking the logs apart. So this is using our properties both ways. So when you're trying to write them as one log, the first thing you want to do is take any power and put it back on the argument. Remember, that was our little property that says if you have a coefficient out front, it goes back on the argument as a power. So this would be log of x squared, since that's base 10. This 1/2 also needs to go back on those, so that would be minus log of x squared y to the 8th to the 1/2. I will apply that in just a second. And then this will be 3 on the z, so plus log z cubed. Okay, this middle one's a little bit tricky because there's a 1/2 power outside. That normally is a square root, but guys, everything inside there is even. This is just going to divide out nicely. So this will be log of x squared. You're just multiplying each of these by 1/2, so we're not even going to have to convert it to a radical. So 2 times 1/2 is just x, and 8 times 1/2 is 4. So that's what we get on those. So once we've taken care of all of our powers and we've simplified anything we see, anything that has, remember, a minus is going to go on the bottom, and anything that has a plus in front of it is going to go on the top. So the x squared and the z cubed are both going to go on the top with our log base, remember, of 10. So remember, I always write the log first and then fill in this part. So I have an x squared up top and a z cubed, because they both had positive logs. The negative log right here is going to go on the bottom, its argument is. Now before you can say you're done, you can reduce the x's inside now that this is all laid out. So this would be log of just one x on top, a z to the 3rd, and a y to the 4th. So I've put that log completely back together. Is everybody okay with the A part one? Are you guys okay? Good, making sure I didn't lose anybody. I know it's storming outside, at least where I live. All right, so let's look at this second one, B part. This one has a big old cubed root on it. That makes our life a little bit tricky. So what I'm going to do first, before I try to split anything up, is I'm going to write that as cubed root of y to the 5th, a cubed root of x to the 4th. I'm going to show you why I do this in just a minute. And a cubed root of y to the 6th. So I actually break each one of them up and give them the cubed root. You can do that. It is legal because everything inside here is multiplication or division. If there was adding or subtracting, it would not be legal. So that's something to always be careful of, but we don't give you anything where this wouldn't be legal. So the reason I wrote it this way is that now I can actually convert each of these into a rational exponent. Remember, anytime you have a radical, it can be converted to a rational exponent by putting the power inside on top and the root as the denominator. So this would be log to the y to the 5/3 on top. So that's a fraction. It's hard to read that, sorry. Then an x to the 4/3 on bottom. And the bottom, this one is actually going to go even. 3 goes into 6 2 times, so that's just y squared. Now, we do have a little bit of an issue because there's y's on top and bottom. I could have canceled that at the beginning and I didn't catch it. And in fact, I am going to do something with that right quick. So let me back up one step. So I'm going to erase this and just back up. Okay. The reason I'm doing this is because it's going to save us a lot of trouble. So this guy right here, we could have reduced at the beginning to just one y in the bottom. Does everybody see that? How there was y's on top and bottom? I didn't catch it because I wasn't paying attention to that. So this bottom would now be x to the 4th and a y to the 1st. Does everybody see that? Because they were all under the radical together, I could have reduced at the beginning. So we're just going to back up just to save us from having to reduce afterwards, because reducing afterwards is actually more painful. So now there's nothing on top except for a 1. And then on bottom we have a cubed root of just y to the 1st. Okay, that's going to save us a little bit of trouble here. So this would still be a 1 on top. This would be x to the 4/3. And this is y to the 1/3. If you'd already done what we did, you could have made this 6/3 and you could have just saw that there was a cancellation of the powers, but it was a little bit trickier because they were fractions. So I hope everybody's okay with that. I just went back and reduced this down first to make my life easier. Okay, so let's talk about what's going on here. So notice you have a number on top, which is a little bit weird. We haven't had that yet. And then on bottom, we have two different bases. So when we split these up, anything that's on top turns into a positive log. So log 1 is going to be a positive log. Everything in the bottom is going to be a negative log. So you just write negative log and then you write the first base. So that would be x to the 4/3. And then you write a negative log and then y to the 1/3. Now, this is the first time we've had one where we actually get a number in our log. And since this is base 10, you can actually see that what I'm about to tell you is true. If there's ever the number 1 inside of a logarithm, the answer is always 0 to that. So let me show you why that's true. If I put in if I put in log of 1, so I have to enter mine in backwards, you notice it gives me 0. That's because this is base 10. 10 to what power equals 1? It's 0. So this part right here is actually null. There's nothing to do with that. So anytime a log pops up with a 1 in the argument, you get nothing from it. It's just the number 0. So that means we're just left with these two. So then I pull my powers to the front and I'm done. So negative 4/3 log of x and negative 1/3 log of y. Now, before you get too upset about this one, this is absolutely not the one on the test. You will either have A or C. So, and this one was put on here just to see if you could catch some of the little tricks that pop up, like getting a log of a number 1. So yes, I will do C, because B is the obvious. We always have like one that's a harder one that's not going to be on the test, and it's B. So let's look at C. C should be a little bit easier because we're putting the logs together again. So let's look at this one. I do see a 1/3 that I'm going to distribute first. So that would be 1/3 natural log of x plus 1. And 1/3 of 3 would just be 1. The bracket ends, so this last part just comes down. We put our powers back up. So that would be the 1/3 and the 4. Everything else just comes around. And then because this is pretty much just in the positive or negative stage, we can put this into its final format. So natural log, put a big parentheses, that would be a cubed root on top since it's a 1/3. And then this would also be on top, the x minus 2, because notice it has a positive in front of its log. Sorry, I almost wrote x plus 2. The only one that ends up on bottom is the x to the 4th because it has a negative in front of its log. So that would be my final answer on that one. We don't have to clean it up any. We just leave it as it's been collected. Is that one okay? Lexi, the 3 in front of the natural log of x minus 2, when I distributed the 1/3 right here, it went to both of those, and 3 divided by 3 is just 1. So notice that turned into a positive 1 in front of that. Does that answer your question? Okay. All right, I need to save this document real quick so that I don't lose any of the ink. So let me save this real quick up to this point. And then we'll look at number 9. I believe we did have a question from number 9. All right. Sorry, my computer is just a little slow with saving. Okay. So for number 9, we had a question about F. So I'm going to scroll down. Okay, for F, we have 3 logs. They're all natural logs all the way across the equation. So since everything has a log, we should be able to get 1 log on each side. Because of the plus between the 2 logs on the right, we should be able to combine them using one of our properties. When there's a plus between 2 logs that have the same base, they're both base E, we can combine the insides by multiplication. So that would be x plus 5 times 3x minus 1. We would need to FOIL that out. So that would be 3x squared minus x plus 15x minus 5. And I'm just going to go ahead and clean that up. That would be 3x squared plus 14x minus 5. Okay, so since you have 1 log on each side and they have the same base, you can set the insides equal. And yes, there is a 3x squared in the problem, but it shows up on both sides. So when you go to move it, it cancels out. So what we're left with is 1 equals 14x minus 5. I would add over 5 and get 6. Divide by 14. And if we reduce that down, that would be 3 over 7. Before we circle that, we need to make sure that it makes all of our insides of our logs greater than 0. So 3 times 3/7 squared plus 1. There's not a single negative in that part, so that's definitely going to be greater than 0. 3/7 plus 5, because that's my second log, is greater than 0. And 3 times 3/7 minus 1, I'll need to double check that one, but that's 9 over 7, and that is bigger than 1 because 9 is divisible by 7 and still has a remainder. So that would be greater than 0 as well. So since all of them keep the logs insides greater than 0, the answer is good. If any of those had turned out negative, we would X out the answer and say no solution. Is that one okay? And like I said, don't worry about D. That's the one that you can actually just mark it out. It's on the final, not on this test. So we'll talk about it on the second class meeting of this week. So are you guys okay with that? All right. So the next one on my list is 10b, which looks to be a long division problem because we're trying to divide f of x by p of x and find the quotient and the remainder. And I cannot use synthetic division even though I really want to because that is x squared. You can only use synthetic division if the part you're dividing by is x to the first. So we have to use long division. So we are trying to put 2x squared minus 2x plus 2 into the polynomial f of x. Notice there is a missing power of x cubed here, so we are going to need a placeholder. So plus 0x cubed plus 6x squared minus 3x plus 1. Our first step is to ask, what do you multiply 2x squared by to make 8x to the fourth? 2 times 4, and I'm going to put it right here because it's going to be x squared times x squared. So a 4x squared times a 2x squared makes an 8x to the fourth. Once you have that number written up here, and I always just line it up with like terms, you multiply it by everything out front. That would be negative 4x cubed. That's why we needed the placeholder for that lineup. And plus 8x squared. To do long division, you change all of your signs once you've multiplied, and that should cancel the first column. This is now positive 4x cubed, negative 2x squared, and bring everything else down. Now we ask, what do you multiply 2x squared by to make 4x cubed? That would be a plus 2 and an x. You multiply just this new part by everything out front. So that would be 4x cubed minus 2x squared plus 4x. We change all of our signs. Cancels, this also cancels, and then we get negative 7x plus 1. Notice that 2x squared cannot go into negative 7x. It has nothing to do with the numbers. It has to do with that you can't put something bigger into something smaller. X to the first is smaller. So now I know my quotient is the 4x squared plus 2x, and my remainder is the part at the bottom where I couldn't divide anymore, so negative 7x plus 1. Are we okay with that one? Part 10b. Excuse me. You guys are awfully quiet. Are we okay? Okay, so let's look at 7a, or excuse me, 12a. So this is the problem where it says you need to find all the values of x such that f of x is greater than 0 and f of x is less than 0 and sketch the graph. Okay, when you see that set of directions, because you do need to be able to recognize it, that always means we're looking for the graph where we look to see if things are going up and down. Okay, so we're looking for something like this. I don't know if that's the exact shape of ours, but that's the kind of thing we're looking for. When are we above the x-axis? When are we below the x-axis? There's essentially 3 big things you need to do to find that. First of all, you need to find all your x-intercepts, so you need to make sure this is factored. This one is. So if you set each of those equal to 0, you get the following x-intercepts. And if you wanted, you could go ahead and plot those on your graph. On the test, all graphs are provided, so you won't have to hand draw them, so you'll know when you're supposed to have something to graph. So negative 4 and negative 1 and positive 3. You then want to figure out, are we above or below the x-axis on each side of each of those dots? So that's when we make a little sign chart. So -4, make sure it goes from least to greatest, -1 and 3. That would be the interval -infinity to -4, -4 to -1, -1 to 3, and 3 to infinity. You put your factors down. After, we'll also have to pick a test value. That's a +4. My test value for this region, I'm going to use -5, -2, 0, and then 4. So remember, we plug those into these, and at the end we're going to look for the overall sign. So -5 plus 4 is negative. -5 minus 3 is negative. -5 plus 1 is negative. 3 negatives right here in this group of factors keeps it negative. -2 plus 4 is positive. -2 minus 3 is negative. -2 plus 1 is negative. 2 negatives make a positive. 0 is nice because you can just pretty much grab the signs that are over here. So that's going to be a negative. 4 plus 4 is positive. 4 minus 3 is positive. 4 plus 1 is positive. 3 positives make a positive. So that means on the left of -4, we're going to be below. On the right of -4, we're going to be above. On the right of -1, we're going to be below again. And on the right of 3, we're going to be above. So you start right here at your first point, and on the left side, you should be down. So you go down. Between the next 2 points, you should be above. So just go up some unknown amount and then come back towards the point. Remember, this is a rough sketch. Go down, because below is next, and then come back up to the point, and finally we go above. The only time you have a bounce, remember, is if you get 2 of the same signs back to back. Is everybody okay with number 12, part A? Oh, wait, I didn't finish it because my blanks aren't here like they are on the test. You also need to tell me when is f of x above 0 and below 0. So this is saving for a second, so give it a second. G asks, what are the positive, negative, and odd and even rules? That's if you want to graph without the chart. Remember, we said there were 2 ways to graph this, by multiplicities and then the end behavior, or you could just do a sign chart. So notice the highest that this would ever be if you multiplied it out would be x to the third. So that would be an odd function, high power. So the highest power is odd. That means that these end behaviors are going different directions. One is down and the other one is up. End behavior means after your last x-intercepts. So the farthest one to the left and the farthest one to the right. If your leading coefficient is positive, then the left side is always down and the right side is always up when you have an odd group. If your leading coefficient was negative, that would be flip-flopped. You'd have up and then down. You don't have to know those behaviors to be able to graph it if you use the chart method, but it is a good way to check yourself so you can kind of see that your graph is correct. Now, the last part of this that I had left out is that we have to write the little interval notation. So on your test, there'll be blanks for this. It'll say f of x is less than 0 and f of x is greater than 0. I don't know which one's on which. It might be greater than 0 on the top, but the most important thing is to pay attention. Less than 0 means your negative intervals. Greater than 0 means your positive intervals. So less than 0 would be -infinity to -4, because that's this column, and -1 to 3. Greater than 0 would be the 2 plus columns. So that would be -4 to -1 and 3 to infinity. So all that does is just kind of show where we were up and down. Now, are we okay with this one now? Sorry, I needed to make sure we did that second part. Everybody okay? All right, so we are getting closer to the end. 13, like I said, don't worry so much about C. Still try it to do for your review points, but I would really focus on A and B for the level of difficulty that we need to expect. This says find the zeros of the given function. Now, when you see that, it could either be a super easy problem or it could be a not so easy problem. It depends on if it is factorable or not. If this thing is factorable, please, please, please do not do the C over D list and all of the synthetic division. For example, part A is factorable. You could try factor by grouping here. If I was to pull out an x squared, and then I have my x plus 5, pull out a negative 16, because that also goes into 80, you also get an x plus 5. You pull the x plus 5 to the front, you get the x squared minus 16, and that factors again. So you have x plus 5, and then x plus 4, x minus 4. You've completely factored this, and your zeros are, remember, your intercepts. So negative 5, negative 4, and 4. Ta-da! That one is not one I would do synthetic division on or any C over D list because it was completely factorable. Is everybody okay with A part? Because I added B on here because I knew A part factored. So I wanted you to see one where what do you do if it doesn't factor? Ali, they do not have to be in order. I'm just looking for did you get the correct 3 answers. I'm not that nitpicky when it comes to listing them unless you're doing something with interval notation, which we're not. We're just giving 3 numbers. Okay, so let me explain why B is a little bit harder. You could still pull an x squared out of the first pair, but there ain't nothing you're pulling out of the second pair, and those are not going to have matching parentheses. So if it's not factorable by anything that we've learned so far, which would be factor by grouping or perfect squares, any of our techniques, that's when we do the C over D list. So it does not factor. Try the C over D list. C is the factors of the last term, the constant. D is the factors of the leading coefficient. So I always make my little list. So C is going to be factors of 15, so plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. The leading coefficient is 1, so there's only one factor group, plus or minus 1. You then place all C's over all possible D's. Well, that's just going to give us the same 4 numbers because you're dividing them all by 1. Remember, if there was another number down here, you would get maybe some fractions. But we just get our same numbers when you divide by 1. So I essentially have 8 different things I would have to run through synthetic division until I find one that works. But that's much better than some of the lists we've given you. So the way it works is you pick one of them, you place it, and this is just the easiest way. I mean, you can plug them into the function, or we did that in class. We plugged them into the function, and then someone said, could we just jump straight into synthetic division? I said, yeah, sure you can. So if you plug it into synthetic division, you get all your coefficients from your polynomial. So that's where I'm getting these numbers from. You bring down the first one, and then you start multiplying. 1 times 1 is 1. Add those, you get 0. 1 times 0 is 0. Add those, you get negative 11. 1 times negative 11 is negative 11. That is not 0, so that means that group doesn't work. Then we try negative 1. Same for coefficients, 1, negative 11, and 15. We bring down the first one, we multiply, so that would be negative 1. We add them, that would be negative 2. We multiply, negative 1 times negative 2 is positive 2. We bring it down, that's negative 9. We multiply, notice that is 24, also not 0. So it's not negative 1 or 1. So let's try 3. And this is why we can't give you a big list, because it would take you forever if there was a huge list. Bring down the 1, that would be 3. Add it, that's 2. Multiply, that's 6. That would be negative 5. Ah, we have found it. Yay! So what we know is that in my box at the end, I already know that positive 3 is a solution, because remember, it worked right here. What you care about the most is what does this leave us with? Because this was x cubed and we divided out a single factor, we now know that this starts with x squared. It's 1 power less. So that's x squared plus 2x minus 5. And that does not factor, but we can use quadratic formula to immediately get the other two answers since this is to the x squared power. So remember, you use 1 is a, 2 is b, and c is negative 5. So negative b plus or minus square root b squared minus 4ac all over 2a. That would be negative 2 plus or minus 2 squared is 4. Negative 4 times 1 times negative 5 would be positive 20 all over 2 times 1, which is 2. And this one does reduce down because that's going to be square root of 24, and we know that square root of 24 is divisible by 4, so 4 times 6. So that would be negative 2 plus or minus 2 on the square root of 6 over 2, which means I can divide everything by 2 on the outside. Not the radical, but the outside numbers are all divisible by 2. So it looks like my other two answers are negative 1 plus or minus the square root of 6. And you don't have to break those up for me like WebAssign makes you do. If you have the plus or minus there, it's good. So 3 total solution. 1 was a nice rational number. The other 2 were radicals, so they were irrational. And like I said, we don't give you the level of difficulty for C on the test just because it's to the 4th power. You'd have to do all that synthetic division at least twice, usually, to be able to get that broken down to something you can use quadratic formula on. So if you can do A and B, you should be good. Are we okay on that one? That was, remember, I forget which number this was. Was it 12? No, 13. So that was 13 A and B. Everybody okay? All right, so I am going to scroll down. Remember, this will be saved as a PDF, so you can look back and look at my ink markings later. So we are now down to 16. And I don't know why this is messing up, because it doesn't like me. All right. Header and footer, there we go. And now my equations have gone to boxes. That's not helpful. Okay, well, let me try to restart this. My equations disappeared for some reason. All right, for some reason, every time we get into a virtual session, towards the end, I think my computer gets mad at me. So therefore, it starts messing with stuff. So okay, I'll have to redo the ink for 13. I will do that after our session's over. It did not save that. So we're looking at 16. Okay. Now, this one is a graph of a rational function. Notice the reason I know that is because there's x's on both top and bottom. So the first thing we want to try to do is see if this is factorable. So if I look at the top, this is negative 6, that's different signs, and we want it to be a negative 1. So I would guess negative 3 and positive 2. On the bottom, it's the same thing, except now it's a plus in the middle, so it actually reverses their signs. So nothing is going to cancel in this because everything is completely different because of the signs. So that means that we have no holes. So I'm going to make my list. So we have to know what is our domain, what is our vertical asymptotes, x-intercepts, Holes, which since nothing is a match exactly, that means we have none of those because nothing's going to cancel. We want to know our y-intercept and whether or not we have a horizontal or an oblique asymptote. Once we know all of that, we'll then be able to get a little bit of information for graphing. So for domain, that's anything, even if it cancels, anything in the bottom that causes something as an issue. So that would be a -3 for the first part and a +2. Now, since neither one of those canceled out, they are both vertical asymptotes. So anything that's still in the bottom after reducing is a vertical asymptote. Anything on top that doesn't cancel out is an x-intercept, and you set those equal to 0, and remember it's an ordered pair. So this would be 3, 0 and -2, 0. You find the y-intercept by plugging in 0 for all of the x's. So this is how we find the y-intercept. That's just -6 over -6, so that's +1. So we do have a y-intercept. And then remember, to figure out your horizontal versus oblique, you look at the highest power of the original problem. Since they are matching, it is horizontal, and it is always the numbers in leading spots. So 1 over 1 would just be 1. So no oblique. The only time you get an oblique, and we said we wouldn't test you on that anyways for like a graphing problem, the only time you would get an oblique is if the top power was higher. If the bottom power is higher, you get y equals 0. If it's the same, you get the coefficients. So this is a lot of information that will help us get our graph started. So the first thing I'm going to do is lay out those vertical asymptotes. Domain and vertical asymptotes are not always the same. Domain is a combination of hole and vertical asymptote. So if there's a hole, the domain will list both of those values, whereas the vertical asymptote only lists the one that's the vertical asymptote. So domain is always everything that was in the bottom, regardless of if it cancels or not. Whereas vertical asymptote is only the things that are still in the bottom after canceling. So there is a difference there between the two. It just so happened that nothing canceled, so they both ended up being vertical asymptotes. We also have a vertical asymptote at +2. We have a y-intercept at 0, 1. So there's that one. We have x-intercepts at 3 and at -2. And we have a horizontal asymptote at 1. Now, I'm pretty much 100% sure that I'm crossing that horizontal asymptote, because if you have a dot on the same line as the horizontal asymptote, you're probably crossing. So when we plug in +1, we'll see that this point is probably going to be up. If it was down, we would just be touching the asymptote. Now, we already promised you that there won't be on the test that crosses the asymptote. So this one's kind of like the, I guess you would consider the challenge one. Now, after you get all the information you have over here plotted on your graph, you want to make a little table of values. That little table of values has to very specifically find points to plug into that are on each side of these vertical asymptotes and x-intercepts. So remember, when we make our list, anything that is a vertical asymptote from left to right or an x-intercept gets put a little mark. So -3, because it's a vertical asymptote, I need to pick something before -3. And then because -2 is an x-intercept, I need to pick something between those two. We don't care so much about this because it's not on the x-axis. And then we need to pick something between -2 and 2. I'll probably pick 1 since I'm curious about that, whether or not it's going up or not. And then +3 as another x-intercept. So any vertical asymptote or x-intercept needs to be a little marker on your table. And you pick something in between or on each side of those numbers. Be careful with if there's a big gap. I always pick something that I haven't got. So I already know kind of this is going down. I want to know what's happening on the right of that y-intercept. So I'm going to pick +1. And then I can pick 2.5 and how about +4. So I'm going to use my calculator because there's not really the best way of doing this. And I'm going to plug these each individually into the original function. You can also plug them into the factors. So -4 squared would be 16, minus a -4 would be +4, and then -6. So my top, I'm not done with this one, but my top here is 14. And then I want to do the bottom. So -4 squared is 16 again, plus -4 would just be -4, and then -6. So that is a 6. So that's 14 over 6. You can reduce it or not because I'm eventually going to turn it into a decimal. Now I need to square -2.5. So the hardest part about this one usually is figuring out all the table stuff. So 2.5 is negative, and then we're going to square that. So that's 6.25. Minus a -2.5 would be +2.5, and then -6. So my numerator is 2.75. And then my denominator will be, it'll be, let's see, 2.5 squared again. It doesn't matter that it's negative because it's getting squared, minus the 2.5, and then -6. That'd be -2.25. So notice that's kind of a nasty fraction, but we don't even care. We're just going to divide it and get a decimal. If you plug in 1, it might be easier to plug it into this part because 1's pretty easy to plug in. That would be -2 times 3, so that would be a -6 on top. And then that'd be 4 times a -1, so that'd be -4 on the bottom. 2.5 is going to come out the same as this one mostly, but there'll be a little bit of a difference because of where the signs are. So 2.5 squared minus 2.5 minus 6, you'll get the -2.25 on top, which means we'll get the 2.75 on bottom. They just switch locations. And then +4, and again, you just have to type all this into your calculator to be sure. 4 minus 3 is 1, 4 plus 2 is 6, so that'd be 6 on top, and that'd be 7 times 2, so that'd be 14 on the bottom. Essentially, you don't even care how perfectly your point is plotted. You just care of what's the location. Is it above the horizontal asymptote or not? So 14 divided by 6, we're just going to get a rough estimate for that. It is about 2.3. So notice that's going to be above that asymptote. So at -4, we're going to be up at 2.3. So that means this guy is going to stay in this top corner. Remember, it has to cradle those asymptotes. So it's stuck up here. If you wanted to plot another point, you can, but it's stuck between its boundaries. If we look at this one, 2.75 divided by -2.25, that is -1.2. So -2.5 is down at -1.2. So notice that does tell me that I look like I'm headed down from this point right here. And then this one ended up being a -6 over a -4. That's actually going to turn out positive. So that's 1.5. So this is what I meant by I was pretty sure that we were going to cross that asymptote on this one because this was actually on the dotted line. So this guy is going up. So you kind of have an x-cubed shape here. You're down on the left of the point of the y-intercept and you're up on the right. But you still can't cross those vertical asymptotes, so you have to go down and up. And then 2.25 is -2.25 divided by 2.75, which is -0.8. So that is down here. So that's going down. And then 6 divided by 14 is 0.42 or 43. So at +4, we're just a little bit under 1. So notice this one looks like it's going to hover on the line but under it. So that is what the graph of this one should look like. This is probably the most complicated. The first two of them are a little bit more basic, but this gets you a lot of information. You saw vertical asymptotes, you saw x-intercepts. The best thing I can tell you on these on the test is just to put every bit of work that you can into it, because there's a lot of pieces and you have to understand how they're kind of fitting together. It's all about factoring to find what pieces the information in the equation tell you, and then honestly you just have to pick a bunch of points, because once you find your vertical asymptotes and your horizontal asymptotes and your x and y intercepts, the only way to feel 100% comfortable with where you're graphing these lines is going to be to plot a lot of x's. So if it takes you plotting more x's than I did, I would save this problem for the end. Honestly, that would be like the last problem that I do on the test. And usually we put it towards the end for that very reason, because you're going to probably want to graph more points to feel comfortable. So G, what's your question? I don't get that. I get that you don't get it, but like, is there a specific question you have about the process? Yeah, the table's not intuitive, because a lot of people don't understand why did I put these little markers through here. The reason I do that is because the only thing that the markers are telling me is that I either touched the x-axis as a point, or I have a boundary where I can't actually cross the x-axis there. So those asymptotes and the x-intercepts are kind of like, remember when we did like a sign chart? They're kind of like our critical values. If you find x values on each side of each of those and plug them into your equation, what you will find is a bunch of ordered pairs. Those ordered pairs then tell you kind of where is the graph at. Because essentially when you look at this, let me try to highlight something here. When you look at this side of this vertical asymptote, okay, just this side, so I'm trying to highlight that so you can see it, you have two choices. The graph is usually either on top of the horizontal asymptote or on bottom. It can't usually be in both unless it crosses. That's the only time. And that's very rare. We gave you one that crosses just so you could see one, because you can't pass the vertical line test if you're in both places at the same time. So by picking the -4, something that's over here on this side, and getting a value, I see that I'm on top of the horizontal asymptote. So that was the reason I wanted to pick -4, was so I could see if I was on top or bottom. So when I picked between -3 and 2, I was looking to see between these two values right here, did I go up or did I go down? Because you're supposed to follow this vertical line either up or down. So seeing that I got a negative value, that shows me the graph is going down. And then because I touched that horizontal asymptote, I made sure I picked something on the right side of it, like +1. That told me that this goes up this vertical asymptote instead of going back down. It gives you a general direction of where you're headed. And then finally, I needed something over here in this region to know if I was on top or on bottom. So it's not like intuitive. I get why you question it, but the whole process is that you're kind of using trial and error, and I'm using these markers kind of as a guide of where should I pick some points. If you wanted, you could pick like 20 points, and you could plot a bunch of them, and then you could say, yes, I feel more confident that I've graphed this correctly. But we try to do the minimal amount and still get the correct graph. Now, did that help everybody else as well? I'm really glad you asked the question, because a lot of people don't understand the table part, and that's because they don't get why we're picking numbers that seem weird, like these 2.5s. Ladies, was that okay for you? I know that y'all haven't said much in a while. Okay, so I'm guessing everybody's okay. Nobody's saying anything. So we're going to do our very last problem for tonight, and then we're going to call it a night because it's almost 11:30. If you still have questions, remember you can come to the session tomorrow night, or you can just email me your questions. I will add them to my list, And what I will do after that is I will make sure that they get on there and they will be part of that video that gets posted. So the last one is not actually graphing, so we don't have to do a table. All we have to do is break this polynomial on top and bottom down as far as we can, and then tell what all the pieces are. So does it have a domain, x-intercepts, y-intercepts, all of that stuff. So essentially the first 1/3 of that graphing problem we just did. So let's look at this part B. So this one I'm going to go ahead and factor it first. I can pull an x out of the top because they all have an x. On the bottom, that's perfect squares, so that's going to be an x plus 1 and an x minus 1. I can factor the trinomial still on top again, so that would be factors of 2 or 2 and 1, and it looks like the 2 is positive. Now, I do see a cancellation, but before I cancel, I'm going to go ahead and write my domain. The domain is everything in the bottom regardless of if it cancels or not. So that means x cannot equal -1 or 1. After you've written that down, go ahead and mark out your x minus 1s. X-intercepts will be anything left on the top, so there's 2 of them. X equals 0 and x plus 2 equals 0. Those are both x-intercepts. So if I solve that other one over, it'll be -2. So that'll be 0, 0 for the first one and -2, 0 for the second one. For the y-intercept, you plug in 0 for all the x's, which everything on top is 0. So that's going to be 0 over -1, which is 0. Which makes sense. Anytime the x-intercept is 0, 0 as one of them, so will be the y-intercept. There is a hole. Okay, so the hole, remember, has to do with this portion right here that canceled. So x minus 1 is our hole, but we set that equal to 0 to find the x coordinate. So that'd be +1. You also have to find a y coordinate. So you plug 1 into the remaining 3 pieces right here. So 1 times 1 plus 2 over 1 plus 1. That would be 1 times 3 over 2. That is 3/2. So this is the ordered pair 1, 3/2. So I'm just going down my list. I know it's in a different order, but we're just going down the list. So the vertical asymptotes is anything in the bottom that didn't cancel. So x plus 1 equals 0 would be x equals -1. Notice the vertical asymptote is an equation, whereas x-intercepts, y-intercepts, and holes are all ordered pairs. So this does look different. And then the question is, do I have a horizontal or an oblique? So your top power is bigger. That means you have an oblique. If they had matched, it would have been horizontal, or if this had been smaller, it would have been horizontal. But if the top one is higher, it's oblique. So that means none for horizontal. To find the oblique, you have to do long division. So x squared minus 1 into x cubed plus x squared minus 2x. X goes into x cubed x times. That makes x cubed minus, that part doesn't have a match, so minus x. Combine that by changing the signs and bring everything down. And then x squared goes into itself exactly once. You do need to write that. And that would be -x squared and +1x. So it actually goes in equally. So this, actually no, that's not a 1x, that'd be a +1. So that is -1x plus 1 is the leftover. That part doesn't really matter. I could have stopped as soon as I got mx plus b on top. So anytime you're doing an oblique, as soon as your top comes out to a slope x and then plus or minus a number, you're pretty much done. So if I was to graph this one, it would be nasty because I would have that slanted asymptote. But we're not asking you to graph. All we asked for was all of the information. So that is everything for that one. I'll leave the intercept y is 0 because if you plug 0 in for all of your x's, the whole top will turn into 0. So do you notice on that function, if you plug 0 into everything on top, the top is 0. If the top is 0, then you get 0, 0 for your intercept. Yeah, you plug into your original function for the y-intercept. For HA over oblique or oblique, there's three possible cases. So notice part A right here. The top is a smaller power than the bottom. That means you can't do long division. So for the A part right here, that would be y equals 0. It's horizontal. That's because you cannot perform long division. So that would be y equals 0. This one, the top power was higher, so I could perform long division and I did get an X out of it. So notice that's why we get an oblique. The last one down here is when you have the matching powers. When you do matching powers, you are allowed to do long division, but all you get is a number. You just get the coefficients. So that would be 6 over 4, which is 3/2. So that would be a horizontal one. The top one was horizontal. The only oblique is ever when you have a power on top that's bigger. So pretty much it boils down to, can you do long division or not? If you can't do long division, or if all you get is a number when you do long division, then you get a horizontal. If you can divide and you get an X out of it when you divide on top, then you know you have an oblique. Is that okay for that? Okay, so we've covered a lot of ground tonight. I'm going to save all this and again post the video. I do hope I answered a great majority of your questions, but you may find as you work through stuff that you still have more. Feel free to email me those questions, or you can come back for tomorrow night's session. And I hope that this was helpful. I hope that you guys got something out of tonight. So I still have to go back and edit number 13 though, so I need to remember to do that because it did not save those the work for that one. Is everybody good?